Hello and welcome back to Let's Code Physics. I am so excited to get Season 3 started with you today. Things are going to be a little bit different in Season 3. For one, I am learning a new programming environment, which we'll talk about in just a minute. For another, based on some changes I've had at work and at home, I'm not going to try to keep up with a Monday, Wednesday, Friday video release schedule. I'm going to work on these projects, record them as I go, produce and then release videos as they're available. So for some weeks, that might mean more than 3 videos a week. For some weeks, that might mean 1 or 2 videos a week. But it's going to result, I think, in a little bit more steady progress on the actual projects that I'm working on, rather than putting together a video and putting it up just to have something. As you might have seen on the AAPT presentation that I gave, which if you haven't seen that yet, I'll include a link to that video in the description below. The big project for Season 3 is going to be the development of a video game, Black Hole Battles, which is where this new programming environment comes from. This is the Unity 3D engine. I've spent some time this summer learning Unity. It's been a real great experience. I've made a couple of simple little, games with just a few elements. I'll show you one of those today. This is the programming environment I'll be using to create Black Hole Battles. I'm going to be looking for feedback from the viewers. So as I develop this game, I would love to hear input not only on how I'm implementing the physics and the programming, but also how I'm implementing the gameplay, how I'm developing the player controls or the options or the enemy controls and things like that. So I'm very much looking forward to hearing input from the viewers. So let's get into talking about this project. So Black Hole Battles is going to be about you, the player, piloting a ship through a randomized field of black holes against an opponent ship. And we'll talk about what that looks like in just a second. So like I said, I've been learning Unity in order to practice this programming system. I have developed a little asteroid navigator game. The game is going to preview in this screen here. So what I can do is when I hit the play button, it's going to give me a little bit of a preview of the game as soon as it compiles. There we go. So I'm controlling the red wedge there. That's the player ship. I'm just using the WASD keys to navigate the ship. There's the other ship. It's technically an enemy ship, but it's not doing anything just yet. When I press the enter key or the space bar, it fires one of these shots. What you'll notice is that over here in the hierarchy, this is the object list for the game, the scroll bar is moving because each time I hit enter, there's a shot object appearing, and then it disappears after a short distance. What I can do is I can navigate around and I can shoot these asteroids, and they'll split in 2, which also creates more objects on the list. And you notice all these asteroids are denoted clone because they're all being created from this asteroid prefab right here. We'll talk about what that means in a minute. And then, of course, let me actually get within the screen. There we go. And then I can also shoot at the enemy ship. So this is behaving more like a concussion blast. So it is firing against the ship. I think I was hitting the wrong button there. And the wonderful thing about Unity is that it takes care of a lot of the basic physics for you. So things like collisions, it can automatically take care of. So it's automatically taking care of all the restitution coefficients and everything between the shot and the ship, or between my ship and one of these asteroids. You can see I can actually push one of the asteroids out of the way. Of course, the asteroid is pushing back on me, making my thrust a little bit more ineffective. I can also set things like the drag on the ships. We're in space, so technically there should be no drag. But I put a little bit of drag on each of these ships just so that way they don't keep floating off everywhere. But I can change the drag. So for example, right now I'm experiencing a linear drag of 1, so that gives me this much of a maximum speed. If I were to decrease the linear drag, let's say down to about 1/4, I would get a lot higher speed. And that's what's neat about it, is I'm not having to recompile the program. See, I'm losing control a little bit there. I would have to use the brakes. There we go. I gotta remember that I have a brakes key. Oh, but the brakes actually accelerates me in the backward direction. So anyway, that's what's neat about this engine, is that I can change these values as I'm playing the game. or as I'm testing the game, I guess I should say, and that way I can fine tune it and not have to change a value, recompile, change a value, recompile, which I'm sure you just love seeing in the previous couple seasons. So this is really neat. I'm really happy with this programming environment. And the wonderful thing is that you can get into the Bayer coding, which I'll show you in just a second, but you can also do things like just click and drag on the objects here just to move them around, to give them a different location. So I can click and drag and move my ship around. I can click and drag to move the other ship around. I can also change the values of the location and things like that over here in the inspector panel, which I guess I'm cutting off the top part of that. Oops. I might need to find a new place for my webcam window. What you notice is that there's not a whole lot of objects in the hierarchy at the beginning. So for example, there's no asteroids at the beginning. In fact, if you go to the game preview here, you see that there's no asteroids anywhere because the asteroids get spawned in by an asteroid spawner code. Hello, Pumpkin. Are you happy to celebrate the launch of Let's Code Physics Season 3? Oh, see, as soon as she notices the webcam light is on, she turns away. What's neat about that is that I don't have to program in those asteroids, which is great because I'm looking to create a randomized field of black holes. So the way I'm practicing that is by creating a randomized field of asteroids. So the way I've been doing that is I have this invisible game object asteroid collider, and it doesn't have anything attached to it except for a spawn asteroids script, which I can preview over here. I'm not going to edit it because opening the editor takes a couple seconds, so I don't want to waste your time with that. But here's the preview for the code. It starts out with a bunch of declarations, just things like the maximum distance the asteroid can be away from the origin of the gameplay. And then there's this subroutine here that gets called once at the beginning, the make asteroids. So what this does is it loops over the number of asteroids here. And so the more difficult the level, the more asteroids, or in the future, the more black holes there are. Let's see, so it creates a random position for the asteroid. So it creates a random X position, random Y position. It's going to check for whether that asteroid is in the way of other asteroids. That's what this Boolean bad location is. Excuse me. Then it sets up a new vector as that new position, and then here's the key is this instantiate command. Basically, that says I want you to look up this resource called asteroid, and that's under the resources folder, the asteroid prefab, and basically I want you to create one of those at this random location. So, for example, right now we've got, how many asteroids was it? Right now we've got 20 asteroids. I think it starts counting at 0, so it's technically 21 asteroids. You know, what's an extra asteroid between friends? So when I run this, there should be 21 asteroids in random locations. So let's go over to the scene, and there you have your 21 asteroids. So this, you can imagine, would be the... let me get a little bit better zoom there. This, you can imagine, would be the playing course. So you'd have your ship trying to make its way through the asteroid field. The enemy ship would be pursuing you once I work out the enemy ship controls. And so what you imagine is actually, let's keep that up so we can let's talk for a minute about what the game is going to look like. So now what I want you to imagine is that instead of asteroids, see, they're in different locations. What I want you to imagine for black hole battles is that instead of asteroids, these are black holes, meaning they're not just little dots sitting there, but that they are exerting a gravitational force on the ship. So right now, the only force exerting on the player ship is the thrust, which is the thing that you, the player, control. So what I want you to imagine, though, is that each one of these is exerting a gravitational force on the ship. So we would program in the good old GM1, M2 over R squared, and have that pull on the ship. So you can imagine as the ship moves forward, it's going to get pulled toward this black hole. If it escapes that one, it'll get pulled toward this black hole. It'll get pulled toward this black hole. Well, that is a mouthful to say. And so what you as the player would have to do is navigate around all these black holes to some, checkpoint at the end, where it's, it lets you escape the sector. Meanwhile, you'll have an enemy ship pursuing you. You have an enemy ship, rotating around, navigating, trying to coerce you to fall into one of the black holes. I don't want this game to be too firepower heavy. I don't really want it to be about blowing the other ship to smithereens, although that is fun. what I'm thinking is at the very basic level, giving both ships just a simple concussion blast, like it's currently doing, to where it knocks the other ship out of the way. So you imagine you're trying to navigate around the black hole. So imagine I'm having to steer really hard to get away from these black holes, and I knock the enemy ship. Well, I knocked them away from a black hole. So my goal would be to avoid the black hole. Okay, so I just fell into a black hole. I just lost the game. And I lost the game. Let's say when I hit this guy with the concussion blast, I'm trying to get him to fall into the black hole. I will increase the thrust or decrease the drag to give it a better maximum speed. This is just for demonstration purposes. So my goal would be to maneuver around and try to maneuver him into the black hole. So I just defeated the bad guy. Oh, I fell into the black hole after him. And then I have to survive the rest of the course in order to get to the checkpoint. Now, of course, the enemy ship is not going to just stand there stationary. The enemy ship needs some kind of control programmed into it. And this is where I'm also looking for viewer input. Is I have not designed the enemy ship controls yet. There's a few options. I'm sure there's an infinity of options I could go with, but that's what I'm looking for from the viewer. So if you were to be playing this game, what type of strategy would you adopt? Would you try to avoid the black holes altogether? Would you try to, kind of skirt your way around the equilibrium points around the black hole? Would you try to build up your speed and use conservation of angular momentum as much as possible? What type of tactic would you take in a scenario like this? Keeping in mind that this field of black holes is different every time. So I am really looking forward to that. That's going to be so I'm really looking forward to this project. Let me show you just a little bit of the code. The code is written in C#. Unity seems to like C# or JavaScript, so I'm having to learn C# finally. Let me show you just a little bit about, for example, this shot that gets fired. This is another object that is not there originally, but gets instantiated when you press the spacebar or the enter key. And so there is a shot fire script that it obeys. So you attach the script to the object. So as soon as the object appears, the program runs the code. So in this script, it's got the shot. That's the main game object that it's working with, but it's also looking for an asteroid. So for example, what it's looking for down here is if it collides with another object. So this is where it has a collider box around it. Actually, it's not a box, excuse me. It's a circle collider. The asteroid has a collider box around it. It's going to look for whether those two colliders have come into contact. So that's how it's able to detect the collision. And let's see, so what it does is it's looking for whether it has hit one of the asteroids. So all the asteroids are tagged with a label asteroid. So basically it says if the other game object has a tag asteroid, so this, object-oriented programming, you just kind of read it like a sentence. Then what you do is you destroy the current game object. So you destroy the shot, and you take the other objects, that's the other rigid body 2D. So all these are stored as rigid body 2Ds. I thought about making this game 3D, but I think I should probably get it down in 2D first. So Black Hole Battles 2 will take place in 3D. Already planning the sequel. So what that one does is it says, okay, what you're going to do is you're going to create 2 new asteroids. So it's going to instantiate new asteroids, but this time the scale is going to be half of the previous scale. So that's how the asteroids are able to pop out, being half the size of the original one. But that only happens if the original one's mass is above a certain threshold. Otherwise, the asteroid gets vaporized; it goes away entirely. So it's kind of cool. The way Unity works is really neat. The way it's able to take care of a lot of the sort of very basic physics for you, so that way you can focus on the gameplay and the more interesting physics. So what I'm going to need to do, let's start working on a to-do list for this project. So the very first thing we're going to need to do is turn the asteroids into black holes. The graphics currently are not terribly that interesting. I am not a graphics expert, so I'll be outsourcing that to my brother. Thank you, Kyle. And what'll happen is we'll need to first program in the gravitational force. We'll make sure that that's working to where the ship experiences a 1/r² gravitational force from each black hole based on their mass. We'll need to randomize the mass and the size of the black holes. and then we can start working on the enemy ship controls, and then we can start working on the different levels, so that the ship goes from one level to the next, figuring out ways to make the levels more difficult. So, like I said, I am very excited about this project. This will be a little bit shorter video for today. You can expect a bit longer ones as the project progresses. Again, I value your feedback. Please let me know here on YouTube or on Twitter or on Facebook. Please let me know your thoughts about the game, about how you would like to see it play, what type of upgrades you'd like to see for the ship, what type of navigation you'd like to see for the enemy ship. And I think this is going to be a really exciting project. So thank you so much for watching. I will see you next time. Bye-bye.